So now we're going to talk about complements and cofunction identities. So I'm going to draw a triangle, a right triangle, and we'll call this angle alpha and this one beta. Now what do we know about these two angles? Well, we know that, let me put a little bit more labeling in. Let's call this A and C and B. We know the sine of alpha is equal to opposite, which would be little a, over hypotenuse, which is C. And we know the cosine of beta, so switch to the other angle now. The cosine of beta is its adjacent side, which is A, over the hypotenuse, which is C. So you see that those two are the same thing. So the sine of alpha is equal to the cosine of beta, okay? Now we know something else about alpha and beta. Because this is a right triangle, this is 90 degrees here, or pi over 2, then we know that alpha plus beta has to equal 90 degrees, or pi over 2, okay? They're said to be complementary angles. So you might remember that from a previous class, that two angles that add up to 90 degrees are complementary. So we're using pi over 2. We're doing it in radians instead of degrees, but those two angles have to be complementary in a right triangle. Okay, so this gives us cofunction identities. So sine and cosine are cofunctions. So you have the sine of some angle, they use t, that's equal to the cosine of the complement of that angle. To represent the complement, they're going to write pi over 2 minus t. See, if you subtracted alpha from both sides here, so you'd have the other angle being pi over 2 minus the original angle, okay? So they're called cofunction identities. So the sine of 30 degrees is equal to the cosine of 60 degrees. So example, sine of 30 degrees is equal to the cosine of 60 degrees. Or I could have the sine of 17 degrees is equal to the cosine of, okay, so what's 90 minus 17? 73. See, these two are adding up to 90 degrees, and their cofunctions, sine and cosine, those cofunctions are equal to each other, okay? So that's what the cofunction identities do. And there's one for each one of them. They write them all out. So the sine of t is equal to the cosine of pi over 2 minus t. The cosine of t is equal to the sine of pi over 2 minus t. And then the tangent of t is equal to the cotangent of pi over 2 minus t. And then the secant of t is equal to the cosecant of pi over 2 minus t. And then let's see, what have I left out? Oh, I didn't do this one the other way. So the cotangent of t is equal to the tangent of pi over 2 minus t. And then the cosecant of t is equal to the secant of pi over 2 minus t. So I think I got them all in there. So there should be 6 of them. So there's the secant, the cosecant. I probably shouldn't do that. Those look like negative signs. Oops. So you've got the secant, the cosecant, the cotangent, the tangent, the cosine, and then the sine was way up there. Okay? So those are called cofunction identities. And so if you know one angle, you can find its cofunction of its complement. We'll give you an example.